Hello friends, today I'm back again trying to introduce a new kind of fuzzer that I'm sort of experimenting with at this point of time. This fuzzer is specifically called Beach Fuzzer. It seems like Beach Fuzzer is a lot more better fuzzer is what I've heard from a lot of other people who would do fuzzing and other aspects. So that got me a little bit of curious, and I decided to move a little bit away from Sully for the time being and try um, Beach Fuzzer and see how it does better as compared to Sully. My initial observation is that it does seem that it's a lot more interactive, and it does have a lot of components which allow debugging very easily. It uses the Windows debugger specifically, so it's easier for it to identify crashes. In this case, I'm going to experiment with a simple M3U file, which is a playlist file that causes a crash in VU player. The exploit has already been published out basically on Exploit TV. I'm just trying to use that exploit and understand how I guess Beach Fuzzer works. It seems like Beach Fuzzer is based on creating the similar sort of a model. Usually most of these fuzzers require you to use some kind of model that defines how a specific file or a protocol looks like. In this case, I am using the M3U model. You can obviously, the only advantage that I did see with Beach is that you can use a random file fuzzing format or a dumb file fuzzing format as well, which is where you just have a file and just provide the file name and then Beach will take care of fuzzing accordingly. So in that regards, that is a good advantage where you don't really want to learn a new file format or a protocol, but just want to do a dumb file fuzzing or a network protocol fuzzing, and that's where I think Beach would be a lot more handy. So to begin with, Beach provides basically a template.xml file. You can basically use that. I'll quickly go over some of the things that I've understood about the specific model. So the model works on a couple of things. One is something called as the XML element called data model that defines how your file format or a protocol should look like. The next is a state model that defines basically the actions that need to be taken place. Since this is basically a file fuzzer, in this case there are basically three actions that get associated. One is the output action, one is the close action. The output is basically stating that, hey, output whatever is in the data model into a specific file that I'm saying to be fuzzed, and then the close is basically closing the file as far as I understand it. And then this action is basically used for an agent, and basically an agent is something that I'll go down. If you look over here, there's an agent which says Windows agent. This is a Windows debugger agent. This agent allows a command line. This is the main aspect of component of I guess Beach that defines how a specific fuzzing case can cause a crash, and that that requires basically the specific. So in this case, I'm basically calling a specific file called fuzz.mpu with vuplayer.exe. It always does a startup on launch viewer. So this is the relation between launching the target process, which would be every time it needs to go through an iteration of this state model. So this is a state model. In the initial part, when it launches, then it will do an output, and then output is done. The file is closed. Basically, at that point of time, the debugger gets attached to the specific executable. That will launch the specific program, see if it crashes. If it doesn't, then it moves on. And that's how the iteration works. It's sort of a state model where the state says open, close, and detect if any crashes between open and close. So it's sort of similar aspect. That's what I've understood. Again, if I get more details as I start playing with it, I'll come in a new series and talk about that. So that was the part of state model and a bit of information about the agent over here. The next model is basically the test, where basically we define actual agents of the agent that we have defined, the state model, which is going to be the state. Publisher is basically the thing in this case that connects the different actions. As we had seen in the state model, the action said, open a file, make an output to that file, and close the file. So this is what comes from the publisher, it seems like, in this specific fuzzer. And again, I have understood only very basically about this fuzzer, but it seemed like it's a good fuzzer and it does do what you need to do. So I'm going to suggest that you guys can also try that. And logger is basically the log file where you need to log certain aspects. Basically, the logger is where if any crashes are logged, those things get logged over there. But in a simplistic sense, the main part is the data model, which is what I feel is always important when I'm writing a fuzzer. So it's sort of similar. In this case, we can see that it has a couple of basic elements, string, blob, and two other elements that does exist. I'm just using the string element for the data model because it's just easier for the specific text write. You can see that I'm defining headers. One thing you have to note is that the elements that you don't want to be mutated can be stated with mutable is equal to false, and that is an important aspect. Obviously, if you want to mutate them, you can go ahead and mutate them. And then these are the values. This is the name of this, the specific string. It doesn't necessarily have to have a name, but it's just a good idea for us as we do complicated or nested fuzzing with nested elements. And then finally, this is the main value that I'm mutating. Once this file has been defined correctly, what you are supposed to do is basically go to the peach fuzzer and then just call peach.exe and then attach a debug symbol so that it's easier for me to see what's going on in detail. Otherwise, it will not give you that many details, and sometimes it's a little bit harder to figure out what's going on. My specific file is called m3.xml as we had defined, and what it's going to do is, as per the data model and the state model, it will start performing the actions. So let's see how things work in this case. So it's performing its fuzzing, and it caught a fault at iteration 3, as you can see. What it will do is it will try to reproduce the same iteration, which is a good aspect of Peach as well. Peach is a little bit more advanced than Sully was. That is definitely true. It does help you understand, especially with the fact that it also does a verification after the crash that indicates that it's a little bit better in that aspect. So it is very good from fuzzing's perspective, especially in cases of files and protocols that are hard to reverse engineer. It's easier to just give it whatever the file or protocol format that you have, and basically allow it to dump fuzzing, which is still not a bad aspect. So as we can see, there are a couple of faults it has reproduced, and I'll let it run 1 or 2 times and I'll show the actual aspect of the faults. And so it seems like pretty much this fuzz has found a lot of faults in the specific program. This is a very simple player that seems to have a lot of issues in terms of reading the playlist files. So I'm going to just stop this at this point of time. So let's go back and let's go to the logs folder. And if you look at the logs folder, there are 2 folders. This is the one that is the most latest. And in the status.txt, it will tell you at which iteration specifically any faults were detected. So that we can clearly see that 3, 10, 11, 12, 13, 14, and 15, and 16 were the ones where the faults were detected. Now, faults is the actual folder. It basically does a division based on, I think, the exploitable strings, or I guess it's based on a specific address or something like that. That is what I've understood so far. And so, good thing to look at is basically it gives you a stack trace. In this case, we can see that EIP has 80, 80, FC93, and ESP is at 0021 DCL. So if you look over here, that's what you will get to see is that this is basically the stack frame, and we can see that the value of EIP, let me bring it up, FC93 is the first value which has caused the fault. So it seems like it's a very simple controlling the EIP pointer sort of exploit. It seems like a vanilla buffer overflow in a generic sense, and you can obviously see that it will give. So it basically tries to do a verification, and at that point in time, it will provide you a specific description. This says a read access violation and instruction pointer, and also it has classified that this is exploitable. So this is some good aspect that comes from I guess speech fuzzing. Definitely you have the file actually that has also. I'm just going to quickly open the file, and it seems like it's a so normal M3 playlist file, and this has caused the crash. So one thing quickly to do is just rename this file as M3U, and then let's launch our favorite. Actually, let's open up immediate debugger so it's easier for us as well to see if it's actually causing the crash or not. I'm just going to attach to Immunity Debugger, and once it starts, let's just drag and drop the file and see if it actually causes the same flashes or not. And this makes your life a lot more easier as a pen tester or as a fuzzer who does this for a living. And there you go. And so we can see the same value represented in ATFC93. If you go a little bit above, you can see the same value, and that is what we had seen in this specific file as well. So it is clearly indication that it is a very good fuzzer. It does indicate the right values. So perfect. That's all about peach fuzzing. As I start exploiting more aspects of peach, I will try to create a small tutorial series with peach. But for now, this is what I have. Alright, thanks everyone.